Let's look at the fragment shader applications. That is, what can we do at the fragment shader stage. We can perform per fragment lighting calculations inside the fragment shaders. Recall that a fragment is a potential pixel that not only has location coordinate but also has color, depth and alpha values. Here is a side-by-side comparison of per vertex lighting and per fragment lighting. Notice that the per fragment lighting is much more smoother and more realistic. Here are three more examples. We can perform smooth shading inside the fragment shader. We can also perform environment mapping, which is mirror-like mapping on top of a smooth surface. So this is basically a reflection of some objects over here on this surface. We can also perform bump mapping. We will study bump mapping later, but this is basically producing a rough surface where you do not have to go and perform minute calculations at every vertex of the surface. Summarizing the fragment shader applications. Lighting calculation can be performed inside the fragment shader on a per fragment basis. Texture mapping, including environment mapping and bump mapping, can also be performed inside the fragment shader. Here is a simple example of a fragment shader where we must define an out variable which contains the color of the pixels. Note that this out variable has been defined by the programmer and is not an inbuilt variable. And this out variable has been assigned values inside the main program, which is a fixed color with one red value, 0 green value, and 0 blue value, and 1 alpha value. This is a Linux version or a Windows version of the program. Note that the Mac version has an inbuilt gl underscore frag color variable defined.